Everybody, it's Tyler here with another Behind the Bot, checking out team number 16176, CDA Lions from Plano. And we're going to be going through, you might have noticed, interesting material choice on this. So we're going to be going through this entire robot, ring mechanism, all the way through the hopper, and of course, shooter, coating, and more. This team did really well, fourth North Texas in the remote matches, so can't wait to find out more about this robot coming here on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting fun so we can continue to make content for you. Stryker makes some of the most revolutionary medical equipment and is a big supporter of FIRST and its participants. If you are looking for an internship or career that supports you being in FIRST, check out careers.stryker.com to learn more. If your team or organization is hosting an off-season event, did you know you can stream it right here on FIRST Updates Now for free? Events that stream on FIRST Updates Now receive an additional 25 to 100% additional viewership because we help you promote your event on a large platform. If you're interested, reach out to us on any of our social platforms, on Discord, or send us an email at admin@firstupdatesnow.com. Let's get your off-season event streaming on FIRST Updates Now. Hurry, dates are booking fast, and we take first come, first serve for all our events.
So Eric, we're going to be starting out with the intake of this robot, following that ring journey through. So start us out with your intake, why you chose this route, any iterations you might have went through as well.
Sure, I'd love to talk about that. So our intake is made of these little PVC pipes that we drilled holes into, and then we use surgical tubing with glue and screws on the inside to hold them together. This black central line actually helps us aim, so that's just sort of a bonus little thing on the intake that we have. And so we use this to intake 3 rings up into the ramp, and I can actually show you that in just a minute. And then they sit behind here in this little hopper area. We stack 3 rings on top of each other. From there, we use sort of this rack and pin mechanism to feed the rings across over to our flywheel shooter, and then they come out the front. And so that's sort of our mechanism all together. So I can show you one of our rings going up.
Yeah, let's go through. I'm really interested to see that your kicker mechanism you have on there as well.
Yeah, so this is how the rings get fed up into the mechanism, like that.
Attention in the FTC pits.
And then from here, I'm actually going to take the rings out because it doesn't work unless we're going to immediately shoot them. Yep. But we use this mechanism right here. It's sort of like a rack and pin mechanism with this sort of circle here. Before we were just using a servo to push this little piece of PVC in and out, and now we've got a little bit of a faster way to do it with this hex motor and this setup right here with our wheel. So when we shoot
on the field,
we're firing this piece across, and that'll help one ring go over into the wheel, drop the next one down, and then finally the last one, and they all get fed across into our flywheel shooter. This is also made out of wood. We're using this little PVC plastic piece right here and Velcro to hold this all together. And when it fires, it resets itself into its sort of standard position so that it doesn't get off within the match. That's all.
One thing that I want to ask you on this here, so when you press that button, it looked like it fired 3 times every time, right?
Yes, sir.
So what happens like if you have a misfire or something like that? You just got to hit it again and go right away?
Yeah, if it has a misfire, that's a good thing. If it has a misfire, it's not a huge deal. That means we can just fire them again, even if there's only 1 or 2 in there. It doesn't matter if it fires 3 times. That won't mess up the other shots. It can fire just 1. We also have a separate button to just fire the mechanism once in case we need to. We also use that for the power shots at the end of the game so that we can hit each one individually.
Makes sense on that. Let's go into your shooter next year. I'd love to hear a little bit more about your flywheel, especially the extra weight added to it as well.
Yeah, so the weight is an interesting point. A lot of teams were struggling with keeping the inertia on their flywheel because the faster you're sending rings through, the more that's slowing down the wheel each time. So we added these metal gears on top that we had lying around to add a little bit more weight to the wheel, so it would keep spinning with a little bit more weight, less deceleration every time a ring came through. So we feed them over. The sort of push from our little piece of plastic feeds them over, helps them get a little bit of speed as they come out. We use this piece of metal right here. This is actually sort of like air conditioning ducting we use. We sort of scrapped this, and that's sort of what we use as our prototype. It's just very handy that it worked out, and we were able to use it. We were able to shape it and mold it to how we wanted it. That comes out here. The rings shouldn't make contact with this little piece of plastic. That's just more of a precaution. If the shooter wasn't working properly, they could just sit right here and the next one can spit them out so they don't get stuck underneath our robot. When we sped up our mechanism using this hex motor and wheel mechanism right here, we were having the issue that the rings weren't coming out fast enough. So in addition to adding weight, we've also done a little bit of coding that will read the battery voltage and sort of up that, and Jackson can tell you a little bit about that later. But that's sort of our main shooting mechanism working well together. We usually go for the high goal, but if we need to, we can go over to the other side if we're trying to play defensive or the other side's blocked, and we can slow down the speed of the shooter so that we can hit in the middle goal on the other side.
Makes a lot of sense. Thanks for telling us about that ring journey as we go through. We're going to be talking to Darcy next, who's going to be going through. First thing I want to ask you on this is the material choice. So we've seen a couple of robots out there made out of plywood, but I always like to hear the reasoning behind that. Sometimes it's budgetary. Sometimes it just works better than what they expected. So tell us a little bit more about why you chose that.
Yeah, so we used wood mostly just for budget because we didn't have as much. We only used like half of our $4,000. But it was also ease of like we can cut the wood into any way we want it.
Yeah.
And it just made it easier for like if we wanted to change it or anything.
So looking at this, when you put stuff together via wood, was there anything that was a little bit more challenging to you because you use wood?
It took a lot more time because we had to hand saw it. And
oh, okay.
We sometimes use a hand saw or a band saw, so it just took a lot of measuring, and then just definitely a lot of hours to put into the wood.
Makes sense. You're also going to be covering the wobble goal mechanisms here. Yeah. One of the things I like to ask about teams with wobble goal mechanisms, we see a very wide range of how big the claw is, right? So I really want to hear about the amount of kind of play you have with that, because it's better to have drivers have more space of air than not. So tell us a little bit more about that.
So we have our, can you open? Yeah. So right here, it's open a bit, and then right here, this kind of just helps it keep. Okay. It just helps it stick better and grip it like much more accurately and better. And then we move it down, then just drop it.
Fair enough on that. We're going to be wrapping up with Jackson, who's going to be talking a little bit more about some of the code. And I think something you mentioned is I don't see any cameras on your robot at all. So talk to me a little bit more about that and some of the other code and sensors that's gone into this.
So just at the beginning of the game, I looked through the game and it just didn't seem like a camera was necessary. A lot of teams are using cameras, but we use these distance sensors right here. So this top distance sensor is placed at the 4-ring height and the bottom at the 1-ring height. So if both sensors sense something, then it's the 4-ring stack. But if only the bottom senses it, then it's the 1, and if none, then it's the 0-ring stack. So when we drive by the ring stack, it takes the lowest measurement from the readings that it drove by, so it can do that. So it's actually a little bit faster than a camera, and it works a lot better. It's much simpler. In autonomous, we can deliver both wobble goals to the start zone, shoot 3 in the high goal, and then take the rings that were in the stack and then shoot those into the high goal as well.
Well, CDA Alliance once again here at the Texas Cup 16176. Thanks for taking the time to speak to us about your robot. Wish you best of luck here at the Texas Cup, and can't wait to see future iterations of your robot as well. Thanks for taking the time.
Thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.